Welcome back to KSET previous year question and solution classes. Today I will discuss classical mechanics part of 2013 paper from the KSET. So here the question is like this: two bodies of mass m. So that means two bodies having equal mass, they are colliding with each other in a stationary frame. That means the reference frame where you are going to calculate is stationary, which is not moving, which is at rest. So the reduced mass of the system is, the options given are 2m, m by 4, m square and m by 2. Okay. So let's see. We know that the reduced mass is calculated by using the formula mu is equal to m1 m2 divided by m1 plus m2. Here m1 is equal to m2 because two masses of a body are equal. So therefore mu is equal to, if m1 is equal to m2 which is equal to m, so then here we can write m into m divided by m plus m, which is equal to m square divided by 2m, and m, the square and m cancel, so answer is m by 2. So the reduced mass mu is equal to m by 2 is the answer. In the given options, option number D is correct. So next question is, a cyclic coordinate does not explicitly appear in Lagrangian only, Hamiltonian only, both Lagrangian and Hamiltonian, and conjugate. So a cyclic coordinate does not explicitly appear in Lagrangian only. In Lagrangian, the cyclic coordinate does not appear. Next, here the third question from the case it is, the equation of motion for a bead sliding on a uniformly rotating wire in a force-free space. In a force-free space means there is no external force for this bead which is sliding on a uniformly rotating wire. Okay, so let's see. So let us consider, here it is x-axis, y-axis and z-axis. Okay, so the wire is like this, and in this wire the wire is rotating. The wire is rotating like this. Okay, so it is rotating like this, and in the wire, so there is a bead which is sliding. So while rotating the wire, it is sliding either downward or upward, whatever may be, you can assume that. Okay, so now we have to calculate, we have to write the equation of motion for this bead in this wire. Okay, so I am going to write first Lagrangian for this bead. So that is, we know that Lagrangian L is equal to kinetic energy minus potential energy, but here in the question they are clearly mentioned that, so the force free, it's a force free space. That means there is no external force for this bead, so I am considering potential energy is 0. So therefore L is equal to kinetic energy. So what is kinetic energy? We know that L is equal to half mv square. So we have to calculate V. We know that, so it has some angle theta with our x-axis and for a y-axis, right? It makes some angle theta. So we have to take a resolution of vector along x-axis and y-axis. That means velocity along x component we have to calculate, and velocity along y component we have to calculate, because it is in between. So the bead is here in between the x and y coordinate, right? So therefore, so let us write first the component. Now I am going to express here Cartesian coordinate to polar coordinate for the simplification. So let us take x is equal to r cos theta, okay, and y is equal to r sin theta, right? So now if we differentiate this, we know we will get x dot is equal to r dot into cos theta minus differentiation of cos theta minus sin theta. That's why I am going to write minus here, and keep as it is r and theta dot. Now Let us differentiate this y with respect to t. So y dot, we know because x dot is nothing but vx and y dot is nothing but vy. So y dot is equal to r dot, keeping sign as it is, sin theta, plus r into differentiation of sin theta is nothing but cos theta into theta dot. Both r is also varies. For example, this is the position vector of a bead. R is also varying, and velocity theta is also varying because it is rotating. The wire is rotating like this. Next, so therefore now we have to calculate the squaring. We have to take a v square, right? So here v is equal to vx plus vy, right? So therefore v is equal to, vx is nothing but x dot and vy is nothing but y dot. Here we have square, so I am going to write this as whole square and v square. So which is equal to x dot square. So what is x dot square? This one, right? So separately I am writing here. So x dot plus y dot whole square. So write x dot is equal to, see, so actually I am writing this as v square is nothing but vx square plus vy square. Sorry, v square is equal to vx square plus vy square. So that is nothing but v square is equal to x dot square plus y dot square. So what is x dot square? If you take that r dot cos theta minus sin theta r into theta dot whole square, and y dot is nothing but r dot sin theta plus r cos theta into theta dot whole square. So let us take this as x dot square. X dot square is nothing but, this is like a minus b whole square. So that is a square plus b square minus 2ab. So like that, which is equal to, a square is nothing but r dot square cos square theta plus b square is nothing but sin square theta into r square theta dot square minus 2 into ab. So it's nothing but r dot cos theta sin theta or theta dot. Okay. Now similarly, if we calculate y dot, so if we calculate y dot square, we will get so what is y dot? We know that r dot square sin square theta plus r square cos square theta into theta dot square minus 2 r dot sin theta plus r cos into r cos theta theta dot. But if we add x dot square plus y dot square, so we will get here we might plus, so here it is plus, so it is plus. So on this plus 2 r dot sin theta r cos theta and this minus 2 is cancelled. Therefore x dot square plus y dot square is equal to r dot square cos square theta plus sin square theta r square theta dot square plus y square is nothing but r dot square sin square theta plus r square cos square theta theta dot square. So see, if you take r dot square and r dot square as a common, r dot square into cos square theta plus sin square theta, plus here in this equation r square theta dot square is constant. So let us take r square theta dot square, remaining is sin square theta plus cos square theta. We know that sin square theta plus cos square theta is equal to 1 and this is also equal to 1. So therefore which is equal to r dot square plus r square theta dot square. So this is the velocity. So therefore we can write here L is equal to half m v square. In place of v square, let us write that as r dot square plus r square theta dot square. So this is our Lagrangian. Okay. So this is our Lagrangian. Now let us write equation of motion. Equation of motion in Lagrangian form. So for Lagrangian, we know that so L is here, right? Therefore d by dt of dou L by dou r dot minus dou L by dou theta, dou r is equal to 0. And if we differentiate this L with respect to r dot, we will get d by dt of m into r dot, right? Because the 2 and 2 cancel. Minus, if we differentiate with respect to r, we will get m or theta dot square, right? Now again differentiate this with respect to t, we will get m r double dot minus m r theta dot square is equal to 0. Therefore r double dot is equal to r theta dot square, because this m and this m cancel. So therefore r double dot is also equal to r square. Theta dot square is nothing but omega square, because theta dot is nothing but omega. Then theta dot square is nothing but omega square. It's angular velocity. So r dot is equal to r square omega square is the answer. So let's see in the given option. Option number A is correct. So the equation of motion for a bead sliding on a uniformly rotating wire in a force free space is r dot is equal to r omega square. So once again I am repeating, L is equal to T of mv square, x is equal to r cos theta, y is equal to r sin theta, x dot is nothing but vx and y dot is nothing but vy. So this is the simplification steps. After simplifying all this, we will get r dot square plus r square theta dot square. Okay. Next, so here let's move on to the question number 12. So that is, the generalized displacement of a rigid body with one point fixed is a rotational about same axis is the statement of C. In rigid dynamics, especially in rigid body, so the particle is rotating, but its position is fixing. Okay, sorry, its axis, the position vector is fixing and the body is rotating. So then it is nothing but Euler's theorem, because we can see the Virial theorem is generally we use it in quantum mechanics and also some part of the classical mechanics while dealing with the kinetic energy and like that. And this equations also we are used in here in rigid dynamics, but in that is especially used in tensors part. Okay, so answer is Euler's theorem. So this is question number 13. If a particle moves under a central force field located at r is equal to 0, describing as a spiral r is equal to e power minus theta, then the force is proportional to position vector r in central force. We have to calculate. Okay, so here they are given r is equal to e power minus theta, right? R is equal to e power minus theta. Next, so we have a expression for this, that is f of r is equal to minus j square u square by mu into d square u by d theta square minus plus u, where u is nothing but 1 by r. Okay, so here if r is equal to e power minus theta, then 1 by r is nothing but e power theta. So therefore u is nothing but e power theta here, right? Next, so from this expression, so let us take f of r is nothing but f of 1 by u is equal to minus j square u square divided by mu into d square u by d theta square plus u. So therefore minus j square u square is nothing but e power 2 theta divided by mu into d square u with respect to d theta square. So differentiate this with 2 times. So du by dt is nothing but e power theta, and again differentiate with respect to theta, again we will get e power theta, because differentiation of e power x is nothing but e power x. So therefore e power 2 theta plus u is nothing but e power theta, u is nothing but e power theta. So therefore minus 2j square, okay, so e power 2 theta divided by mu into, so see d square u by d theta square is nothing but e power theta, so that is also e power theta, e power theta. So 2 into e power theta, e power theta plus e power theta, 2 into e power theta. So therefore which is equal to 2 into e power theta. So minus j square 2 e power 2 theta theta e power 3 theta divided by mu. So e power 3 theta is nothing but, so e power theta is u, so then e power 3 theta is nothing but u cube, but u is equal to 1 by r. If u cube is nothing but 1 by r cube, so therefore minus j square 2 mu is equal to 1 by into 1 by r cube. So therefore f of r is directly proportional to 1 by r cube or inversely proportional to r cube. So from the given expression we can conclude that answer is r cube. So option C is correct. Okay, so this is the solution. So this is question number 14. Two photons x and y are moving in the direction opposite to each with the velocity c relative to an observer in the inertial frame. The velocity of the photon x related to the photon y. So two photons x and y are moving in their opposite direction. So one is coming from this side, another one is coming from this side. See, here there is a trick. If suppose two bodies are moving in opposite direction, we should use in the expression positive sign. So that is u is equal to u prime plus v divided by 1 plus u prime v by c. Here it is plus if they are moving in opposite direction. Here you have to take minus if they are moving in same direction. So here the two photons having same velocity c. So that is u prime is nothing but c and v is also nothing but c divided by 1 plus c into c by c. So which is equal to c plus c is nothing but divided by 1 plus c square by c, right? Actually the expression here it is c square in the denominator, c square, and c square cancel. In the numerator 2c divided by the denominator 1 plus 1 2. So 2 and 2 cancel, answer is C. So option C is correct. For C it is C. So this is the question number 15. The Lagrangian for a 3-particle system is given by L is equal to of neta 1 square plus neta 2 square plus neta 3 square minus alpha square into neta 1 square plus neta 2 dot square plus neta 3 dot square minus neta 1 neta 2. Where alpha is real, then one of the normal coordinates as frequency omega. So you have to calculate one of the omega from these 4 options, and here the Lagrangian is given. This is T and this is V. So this is under the part of small oscillation. Okay, so in small oscillation we should use the eigenvalues and eigenvector concept. So here we know that L is equal to T minus V, where T is here, T is nothing but 1 by 2 into neta 1 dot square plus neta 2 dot square plus neta 3 dot square, and V is nothing but alpha square into neta 1 dot square plus neta 2 dot square plus neta 3 dot square minus neta 1 into neta 2. And here to calculate this eigen frequency or frequency, we use a expression V minus omega square T is equal to 0. So what is T matrix? T matrix is nothing but so the coefficients of n1 square, n1 dot square. So that is 1 by 2 into, here it is 1 0 0 0 1 0 0 0 1. Okay, and here V is equal to alpha square into, so what is neta 1 dot square coefficient? 1, and neta 2 dot square is 1, and neta 3 dot square is 1, and all other coefficients except this n1 2. So that is so 0, and it is alpha square, so minus alpha square 0 0. In all other coefficient it is 0. Okay, so our alpha square is not if we did not multiply, you can write this as a 1. Here it is minus, so I am going to write minus 1. Okay, so sorry, this is 1 3, so I am going to write minus 1 here. So because this element is 1 2 coefficient, this is 2 1 coefficient, this is 2 2 3 coefficient, like matrix elements. So now if you substitute, like if you write like this, you will get alpha square 0 minus 1 minus alpha square 0 alpha square 0 0 0 alpha square minus omega square 0 0 and 0 omega square 0 and 0 0 omega square. Determinant is equal to 0. Okay, next, so therefore, so after calculating this, we will get alpha square minus omega square 0 minus alpha square 0 alpha square minus omega square 0 and 0 0 alpha square minus omega square. Determinant is equal to 0. So if we take this, if we solve this equation, we will get alpha square minus omega square and alpha square minus omega square and alpha square minus plus omega square is equal to 0. So why? Because alpha square minus omega square into alpha square minus omega square minus alpha square minus omega square minus 0 is equal to 0 and 0. If you take this one and this is also 0, this is the determinant. So therefore simplifying we will get alpha square minus omega square is equal to 0 and alpha square is equal to omega square if you solve this equation. So here they asked one of the frequency omega. So here from the given option of omega square is equal to alpha square we got. So option A is correct. So for this question option A is correct. Next, an electron at rest is made to move with a velocity root 3 by 2 c. Its mass then becomes, we know that for m is equal to m naught into gamma in a relativistic case. So therefore m is equal to m naught into gamma is nothing but 1 by square root of 1 minus v square by c square. So m naught by this equation can be written as c square minus v square by c square is equal to m. So therefore m is equal to if we take this here, so m is equal to m naught divided by square root of, so here v velocity v is given root 3 by 2 c. So c square minus root 3 by 2 is nothing but 3 by 2 3 by 4 c square by c square, right? So c square cancel. So here, okay, so let's see, don't do this one and this one. So let's see, we can easily substitute for this equation only. So that is m is equal to m naught divided by square root of 1 minus v square is nothing but 3 by 4 c square. In the denominator we have c square. So m is equal to m naught. So here root of c square and c square cancel now, right? So 3 by 4 minus 3 by 4. So m naught divided by 4 minus 3 is nothing but root of 1 by 4. So therefore m is equal to m naught divided by, so 1 by 4, if it come outside it will becomes 1 by 2. So therefore m naught 2 will goes to numerator 2 m naught. So m is equal to 2 m naught. M is equal to 2 m naught is the answer. So option A is correct. A linear transformation of a generalized coordinate q and the corresponding momentum p and q and p to q, p is given by p is okay. So first I will discuss this one. For a charged particle in an electromagnetic field, the canonical momentum is, so this is very easy. So let's see, we have to calculate the generalized momentum. So the generalized momentum is p k is equal to dou L by dou q k dot. So what is Lagrangian? We know that L is equal to kinetic energy minus potential energy. So L is equal to kinetic energy is nothing but we know that of mv square minus potential energy for a electromagnetic field. For a electromagnetic field, potential energy is, okay, so q phi, okay, and minus q into v dot a, where phi is a scalar potential, a is a vector potential and v is a velocity for this potential energy. So therefore L is equal to minus of q phi minus q v dot a, so which is equal to of m v square minus q phi plus q into v dot a. So this is our L. We have to calculate pk is equal to dou L by dou q dot, and q dot is nothing but velocity, right? If q is x and q dot is nothing but x dot, which is equal to velocity. So therefore p is equal to, differentiate this L with respect to velocity. So of mv square minus q phi plus q into v dot a. If you differentiate with respect to velocity, we will get mv and 2 to cancel minus q phi. There is no velocity here and it will 0, and plus q into velocity 1, so a. So mv plus qa. So in terms CGS, we will divide it by c. So P is equal to mv plus qa by c. mv plus qa by c. So option A is correct. So the question number 11, a linear transformation of a generalized coordinate q and the corresponding momentum p and q and p to q, so let q is given q plus p and p is given q plus alpha p, is canonical with the value of the constants alpha is. So alpha is, so here q and p is canonical. So by using this condition, we have to calculate the value of alpha in these 4 options. We know that for a Jacobian transformation, dou q by, for a canonical condition, dou q by dou q into dou q by dou p and dou p by dou q and dou p by dou p, it has to be 1, right? So now q, here in the question they are given q is equal to q plus p, q is equal to q plus p, and p is equal to q plus alpha p, right? So therefore which is equal to dou q by dou q is nothing but 0 and dou q by dou p is nothing but 1, dou p by dou q 1 and dou p by dou q, dou p by dou p is alpha, right, which is equal to 1, right? Okay. So next, see dou q by dou q, sorry, it is 1. Now it is nothing but alpha minus 1. If you take a determinant, alpha minus 1 is equal to 1. So therefore alpha is equal to, if it is sent to right side, it will becomes 1 plus 1. So alpha is equal to 2. So in the given options, alpha is equal to 2. So option number D is correct. Okay. Next, question number 12, the value of a Poisson bracket A dot R and B dot P, where A and B are constant vectors, is. So from this equation, so from the given options, which of the following is correct? They are given A dot R comma B dot P. So if you take A and B as a common, so it will becomes AB R comma P. We know that R comma P Poisson bracket is 1, so AB is the answer. So option A is correct. So this is the question number 13. The canonical transformation corresponds to the generating function f is equal to summation I qi pi. It is identity transformation or reflection transformation, exchange transformation or reflection exchange transformation. So this is the canonical transformation corresponds to the generating function is identity transformation. Okay. So option A is correct. And the next question number 14, which one of the following is not the generating function of the canonical transformation? P is equal to 1 by q and q is equal to p q square. Option, these are the given. So in these four options we should verify which of the following is not a generating function. So to calculate that, let's see. So here let us consider for option number A, they are given f of q comma q, which is equal to q by q. So let's verify it is a generating function or not. So how to verify that? So we know that, so missing is equal to dou f by dou present. So this is the trick, we have to identify the condition. So missing here, if this present, if I consider this present as a dou small q, the missing must be small p, and which is dou f. So which is equal to dou f. So this is f. Let us differentiate this with respect to small q. So 1 by q. So small p is 1 by q. And another one is capital Q is present. So capital P is missing. We know that capital P is equal to minus of dou f by dou present is q. Okay, so present is q. So therefore which is equal to minus of, in the if we differentiate this with respect to q, we will get minus of q square, right? So minus into minus plus q by q square, this is capital P. So therefore q is equal to q square into p. They are given p is equal to 1 by q and q is equal to p q square. We got all these, right? So from this equation we will get the given question. So it is a generating function. So option A is generating function. Actually they are asked not generating function. Which one is not a generating function, that we have to identify. Next, for this I am taking B. So here f of q comma p is given, which is equal to 2 into root of q into p, capital P. Okay. So now let us differentiate this. Present is q and missing is p. So p is equal to dou f by dou present. So differentiate this. So let us take this as 2 into root p into root q. Okay. So differentiate this with respect to q, we will get 2 into root p into differentiation of root x is nothing but 1 by 2 into 1 by root q, right? And 2 cancel. So therefore root of p by q is given. So which is p, right? So therefore p by q is nothing but p square, and q is equal to p square by p. Next, so here also they are missing is q. Q is equal to dou f by dou p. So again here 2 into root q into differentiate this with respect to p. So we will get divided by 2 into 1 by 2 root x. So do root p. So again root q by p is q, and therefore q square is nothing but q by p, right? And q is equal to p into q square. So this is, we got q is equal to p q square. One of the function is got. And if we consider this equation 1 and this equation 2, again we will get p is equal to 1 by q. So therefore this is also generating function. B is also generating function. Now let's verify third one. So that is f of P comma Q, which is equal to P by Q. So which is missing? Capital Q is missing, and which is present? P, capital P is present, which is equal to, differentiate with respect to P, we will get 1 by Q. And from here again small p is missing, and so dou F by small q is present, so which is equal to, differentiate this, it is, we will get minus p divided by q square. Okay, so therefore q is equal to 1 by q we got, and we know that small p is nothing but, so actually this is p by small p, so therefore, so this is small p, so therefore missing is small q is equal to minus of dou f by dou p, so therefore p by p square, so minus into minus plus, so therefore q is equal to p by p square, right? And therefore, and also 1 by q is nothing but 1 by q. So sorry, this is p by p, so therefore, so let us forget this all. Let us take f of p comma small p, which is equal to p by p. This is small p and this is capital P. So therefore missing is nothing but q minus of dou f divided by present is dou small p, which is equal to minus of p, in the denominator we have minus small p, so it is like 1 by x, differentiation of 1 by x is minus 1 by x square, so minus 1 by p square, minus into minus plus, so p by p square is equal to q. Next, here from the capital P we know that q is equal to dou f by dou capital P, which is nothing but 1 by p. So this is equation number 2 and this is equation number 1. So from this equation 1 and 2 we can conclude that, so P is equal to 1 by q and the P is equal to 1 by q. If you substitute here, we will get q is equal to p q square. Okay, so option 3 is also generating function. Similarly, if we calculate option D, okay, so option D is q by p small q, so which is f of q comma p, so which is present, capital P is present, so capital P is equal to dou f by dou present is nothing but q, so which is 1 by p. So and small q is equal to minus dou f by dou capital small p, which is equal to minus into minus of 1 by p square, so which is q is equal to plus 1 by p square. Q is equal to plus 1 by p square is also not there in the question, okay, and also capital P is equal to minus 1 by p is also not there in the question, but capital P is equal to, we have capital 1 by q, so option D is correct. That means option D is not a generating function. So next question, which of the following statement is false? The Poisson bracket of a momentum conjugate to the cyclic coordinate with Hamiltonian vanishes. Lagrangian bracket is invariant under canonical transformation. Poisson bracket changes sign under commutation of canonical dynamic variables. Lagrangian bracket is commute with respect to the conventional dynamic variable. Okay, so here the option number D is correct. So why? Because if we change the Poisson bracket, if we reverse the Poisson bracket, it will get negative sign. So option D is correct. And also Lagrangian bracket is invariant under canonical transformation. And also the Poisson bracket of momentum conjugate to the cyclic coordinate with Hamiltonian vanishes. Okay, only this one is wrong. So option D is correct. Next, option number 6, question number 16. If x comma h is equal to 0, y comma h is equal to 0, the value of h of x comma y. So obviously it is also 0. So option A is correct. Next, the value of d by dt of qi comma pi is always 0, no, always 1, no, 0 when I is equal to j, I is not equal to j, or 0 when I is equal to j. So which is 0 when I is equal to j? Because if I is equal to j, it is like qx comma px, and we will get qx comma px is nothing but 1. So differentiation of constant with respect to time is 0. So option D is correct. Next, if the Hamiltonian of a system is h is equal to p square by 2m plus v of q, the value of q comma p comma h is. Okay. So question number 18. So let's solve. See, this is the commutation. They are given p comma h, where h is p square by 2m plus v of q. Potential is a function of q. So let's write p comma h is nothing but dou p by dou q into dou h by dou p minus dou h by dou q into dou p by dou p. We know that dou p by dou q is 0 because p is nothing but mv. There is no x component, so it is 0. And dou h by dou p is also 0. And dou h by dou q, see here h is nothing but p square by 2m plus vq. So therefore this term will be 0, but this term here we can write this as minus of dou vq by dou q into, and this dou p by dou p is 1. So answer is minus of dou vq by dou q. Okay. Next, so this is p comma h, and again if you take p comma h comma p is nothing but p comma minus of dou vq by dou q. Again we write this as dou p by dou q and minus of dou by dou v by dou q of dou p minus dou by dou q of minus of dou vq by dou q into dou p by dou p, and dou p by dou q is 0, and also dou p by dou v by dou q is nothing but see, it is a component of velocity and it is position, so again it is 0. And minus into minus plus dou by dou q square and v dou into dou square of vq into dou p by dou p is nothing 1. So therefore dou square vq by dou q square is the answer. So option C is correct. So option C is correct. Next, if h is constant of motion, the value of p comma h is, we know that p comma h is nothing but dou p by dou q into dou h by dou p minus dou h by dou q into dou p by dou p. So which is equal to dou p by dou q is 0 and dou h by dou p is also 0, and dou h by dou q, we know that by the definition of Hamiltonian, dou h by dou q is nothing but p dot. So therefore which is p dot, and dou p by dou p is 1, so answer is p dot. And so therefore p comma h is nothing but p dot, and p comma h is nothing but p comma p dot, right? So therefore p comma p dot is nothing but dou p by dou q into dou p dot by dou p minus dou p dot divided by dou q into dou p by dou p. Okay, so again it is 0 and again which is 0 and dou p by dou p is 1 and dou p dot by dou q is nothing but p double dot. Okay, so answer option number D is correct.